Well, welcome to tonight's last lecture in the Cosmic Origins. Thank you so much for being here with us. After tonight's lecture, in 6 lectures you will know as much as our cosmologist, which means that you know about 5% of what's going on. Today, I really felt like an impresario in a nightmare. Yesterday we got a call from our speaker, Carolyn Porco, saying that she had had an accident and that she was not going to be here. In fact, she's not here. She's okay, but she wasn't able to travel. So then we went into panic mode, and we figured out, well, what could we do? And we said, well, maybe we could have Peter Smith come and talk to us about water on Mars and talk about life on Mars. And then we said, well, maybe we can have Jonathan Lunine talk about his book, How Do You Make a Habitable Planet? Or we can go on to Roy Parker and say, well, how do we go from chemistry to self-replicating chemistry? Well, the bottom line is that we have a big bench. And we decided, though, in the end, that perhaps we should end the talks with our star speaker, and that's with Chris Impey. And Chris is going to give us a lecture tonight. And he'll tell us that we know 5% of what's out there about life. Today, in particular, I want to thank, I hope you bear with me a bit, being the last lecture. I want to thank our underwriters, those that make this possible. The Arizona Daily Star, Cox Communication, Bob Davis and Innovation Park Place, Stantec, DPR, those friends of the college, the Galileo Circle members, Godad Design, all these beautiful things are from Godad, Raytheon. Research Corporation is special in this as well because they give us money so that we can have the funds to pay teachers from middle and high school to come and take credit for these and take the material back to the classes. So thank you for that. Unisource Energy and Ventana Medical Systems. And again, thank you all for attending this as well. Speaking of the teachers, I just want to point, and maybe they can stand up, but John Pollard, who is a faculty member in chemistry, and Margaret Wilch, where's Margaret? From Tucson High, are the ones that have actually got it all together, but those are all the teachers that are here with us. Thank you so much, and don't tell your students that we don't know anything. Actually, do tell them. They have to figure it out. We have a small lecture series committee that puts these things together and tries to think them out. And last year, we asked all of you for your comments of what you would like to hear from us, and the great majority of answers to us was cosmology. So we urge you to let us know again what topics you're interested in and see if we can package them together. Carl Philbaum, who was a person that actually did that filling of Centennial Hall, and he's the one that also has the funky pictures that come out here. He's a friend of the college, and we thank him for that. The Arizona Public Media for filming these lectures. They now have been highlighted in iTunes as something worthy to look at. And Stuart Glogoff, who actually posts the podcast. I do encourage you all to look for these and past lectures in the College of Science website. Starizona for making a contribution towards the telescope drawing. And everybody from the College of Science has to not draw. So only you folks can actually get it. And Centennial Hall staff has made it possible for us to do this as well as it's been working. So thank to all. And for those of you that cannot get enough of astronomy, there is actually a lecture series. Stuart is offering it. You have to go to the website and see when that starts. It starts actually March 28th, and it runs throughout the semester. So between the the telescope in Mount Lemmon and the lecture series of Steward Observatory, you can continue learning about our cosmos. And I just want to do one special thing right now. There are, amazingly enough, young kids from middle school and some even from elementary school that are coming here to listen to these lecture series. And I've met a few of them here and there. And of course, since I'm old, I don't remember their names but I did remember two of them. And I'd like to ask them to come up here. It's Alfredo and Alex Diaz, who come up here. Are you around by any chance? Come up here. I want to give you a certificate. And the rest of you that I didn't get to meet, if you just let me know who you are, I'll give you a certificate later on. But thank you so much, and Chris.
It's great to be back, although not under these circumstances necessarily. But sometimes life, throws you a curve. I talked to Carolyn, and she's fine. She has the penalty of living in a place where there's ice. I try and rule ice out of my life. That's why I live here. And you just have to go with the flow in these things. Things don't always go exactly as you want, and they change. And you have to be willing to adapt to the circumstances. My caveat as I start is that I'm not an astrobiologist and I'm not a planetary scientist. I have a hobby side interest in that. The research I do is if it's closer than 1 billion light years, I don't care. So that includes everything I'm going to talk about tonight. But I really care a lot about everything I'm going to talk about tonight. So I and we all, I'm sure, wish Carolyn well. She's fine, but she did take a nasty fall. So she's not able to be here. Now, since it's not my subject matter, that's the big caveat. And I'll follow this very well understood process in the upper echelons of academia, where you say basically any you want and people won't know. So, and before I start, I want to make one public service announcement. There should be no guns in here. So, now, as you know, that may not last. I'm just telling you that if I come back here in a future date and you are packing heat, I am going to pack heat. I'm going to pack more heat than you. I'm going to pack so much heat, I'll scare you, okay? So just let's have that clear, because there's a lot of you, okay? Thank you. So the subject matter tonight is, in Carolyn's title, the oldest question, the oldest and perhaps one of the most profound questions about the universe we live in, which is whether this extraordinary experiment in biology that took place in this one little remote cubbyhole, this little corner of the universe, starting 4 billion years ago, is unique. That's an extraordinarily profound and simple question. The architect and visionary Buckminster Fuller put it very nicely, that dichotomy. Either we are alone in the universe or we're not. Either way, the implications are staggering. And they really are. And so what you see is the end of a long progression that is the Copernican revolution, which continues to this day. And as we see, it's a progression of ignominy, where we find ourselves to be unexceptional in our position relative to an average star within an average galaxy in one region of a universe filled with galaxies. We also find we're not even made of the material that the universe is overwhelmingly made of. And perhaps the final steps in the Copernican revolution, this progression of displacement of us in importance, would be one that I alluded to in my talk, the possibility of other universes beyond our view, and the possibility that there are other inhabited, not just habitable, but habited planets elsewhere in the universe. So that's the subject for tonight. And of course, you know already this is a talk with lousy tension, because you know the answer. I'm not going to break the news to you tonight. We are still the only living planet we know of in the universe. So, I'll just leave a little while for you to leave if you want, because I just gave you the answer. That's the answer. We're it. So we'll just be staring at our navels this evening and just being very happy that we're alive because we don't know of anywhere else that is. But the game is getting interesting, and I hope I can persuade you that not just in some misty, distant future, but in approximate future, in our lifetimes, we may learn the answer to this question, an extraordinary question to answer. But first, let me reiterate that it is a subject in its infancy, and the amount we know vastly exceeds what we don't know in a similar way to the universe contents. For example, the biosphere, the thing that we should know the best, we don't fully understand. Most of the microbial diversity of the biosphere is unexplored, untapped. Those microbes are uncultured in the lab. We really don't understand them very well. We've only poked around the solar system with our robotic and remote sensing probes in a few locations. We have explored or even diagnosed in the simplest way a tiny fraction of the habitable real estate in the Milky Way galaxy. And the activity of SETI, the abbreviation for the Search for Extraterrestrial Intelligence, is in its infancy and has, they would admit, have only searched a tiny fraction of all the possible stars that could have planets sending signals to us. So this is a subject where we're just starting to get going. The context for life in the universe is fairly simple, and you've heard it built up in stages in previous talks. The first part is, of course, chemistry, and also the fact that there are places where life can exist. So we understand that as a natural byproduct of star formation, planets will form. It's an unexceptional physical process. Collapsing clouds of gas and dust form a disk. Most of the mass goes into the star. A small fraction is left over and forms rocky objects that glom together by accretion. Radiation from the young star drives out the residual gas, and so you end up with small rocky objects near the star and larger, cooler objects which can accrete gassy envelopes further out. Those are the gas giants. It turns out that that's maybe a little bit of a just so story to explain our solar system, because the planets we've started to find elsewhere do not follow this simple picture. But certainly we expect planets to form naturally wherever stars form, and that's what we've been finding. We also know that the ingredients for life are widespread. So you might worry in the business of astrobiology whether the requirement that life be made with carbon and use water is overly restrictive. And I would say no. I would say we should open our minds to life doesn't have that basis. But there's no need to look beyond that, because as you can see, carbon is one of the most abundant elements in the universe, made in stars, distributed into the space between stars. The long journey of all the carbon atoms in our bodies probably encompasses dozens or even hundreds of generations of stars over cosmic time. An extraordinary story. Each carbon atom has a different story, in fact. But the ingredient is there, and water is one of the most abundant molecules in the universe. So even if we say that life needs those things, that is not restrictive in a cosmic sense. Also, the universe has been getting more fit for life as cosmic time passes, because stars have been progressively making more carbon, and so the fact that we live in an ancient universe should not surprise us, because we couldn't exist in a universe 100 million years after it formed. Even though there were stars then, they were pristine stars made only of hydrogen and helium, with no planets around them. There was no grit to grow the pearl. And so back in the early universe, there probably was no life. So the ingredients are widespread, and the ingredients are put out there by cycles of star birth and death. And you've heard some about that in previous lecture. So these heavy elements are cooked inside stars by fusion, are ejected into interstellar space, where they become part of a new generation of stars. And this cyclic process of star birth and death, the creation of heavy elements by fusion deep inside stars. Of course, all of these fusion events for our atoms happened at least 4.5 billion years ago, because they preceded the formation of the Earth and the Sun. So this is a life story of stars, but it's also our life story. It's the story of our life, of our biology. And they couldn't exist. If stars were selfish and hoarded their heavy elements in their cores and just shrunk into stellar corpses,